All right, let's talk about a piece of technology that, frankly, sounds a lot like science fiction. But it's very real, and it's set to completely redefine how we think about data security. It's called homomorphic encryption, and it solves a fundamental problem we've been stuck with since the cloud became a thing. For decades, the answer to this question has always been yes, it's been a given. If you want to get any real value from your data, if you want to analyze it, learn from it, compute on it, you've had to expose it. But what if that core trade-off just wasn't necessary anymore? So, to really appreciate why this is so revolutionary, we have to start with the central dilemma of cloud computing as it exists today. This forced choice between actually using your data and keeping it private. And this really gets to the heart of the problem, doesn't it? The very moment a cloud server needs to do anything with your data, you are forced to hand over the keys. The data is decrypted, and in that instant, on a machine you don't control, it becomes completely vulnerable. So here's the standard flow we're all used to. Your data gets encrypted while it's in transit to the server. That's good. That's standard practice. But then, to do any work, the server has to decrypt it into plain text. And that third step, that's the whole problem right there. That's the security boundary that gets breached every single time. And let's be clear about what's sitting in that vulnerable gap. We're not talking about trivial stuff. We are talking about our most sensitive information, our financial records, our personal health data, and even deep usage analytics that paint a very, very detailed picture of our lives. So for years, the challenge for engineers has been crystal clear. How do we close that vulnerability gap? How can we possibly use a server's massive processing power without ever actually showing it our raw data? Well, this requires a completely different approach. And this is that different approach, homomorphic encryption. From a security engineering perspective, the definition is as simple as it is powerful. It sets a new rule. The server can manipulate the encrypted container, but it can never see what's inside. The data stays encrypted from the second it leaves your machine until the processed result comes back. Now, I know what you're probably thinking. This sounds almost paradoxical. How on earth can you compute on data that you can't even read? So let's walk through a really simple, intuitive example to make this concrete. We're going to add two numbers together without the server ever knowing what those numbers are. Okay, first step happens on our side, the client side. We take our first number, let's just say it's 5, and we encrypt it. Now it's just this encrypted block of data. The server has absolutely no idea what its original value was. And we do the exact same thing with our second number, 10. Again, it gets locked away into an encrypted form. So now we have our two pieces of ciphertext ready to go. And here's where the magic really happens. We send these two encrypted blocks to the cloud. The server then applies a special kind of addition function, but it does it directly on the encrypted data. It combines them into a new encrypted block, all without ever seeing the numbers 5 or 10. This server finishes its job and sends this even still encrypted result back to us, back inside our trusted environment where we and only we hold the decryption key. This sensitive operation is complete and our data was never, ever exposed. And only now, safely back on our own machine, do we use our key and decrypt the result. And what do we see? 15. The correct sum. The computation was a success, and privacy was never compromised for even a nanosecond. So look, this is far more than just a neat mathematical trick. This is a foundational technology that unlocks entirely new classes of secure applications. Let's talk for a second about what this actually enables in the real world. This is a complete game changer. I mean, imagine running complex analytics on a massive dataset in the cloud without ever giving the cloud provider your raw data. Think about using a powerful AI model to analyze a sensitive medical scan where the AI company never actually sees the scan itself, or enabling multiple companies to collaborate and analyze a shared dataset without any of them having to reveal their own private inputs. This right here is the new paradigm. We can finally separate data utility from data exposure. We get to use all the power of the cloud without the fundamental privacy risk we've always had to accept. For years, this has been the holy grail of private computation. Now, let's be realistic. This technology is still very computationally intensive. There are performance trade-offs to consider, for sure. But the fundamental capability is here, and it's getting faster all the time. And that forces us to ask an incredibly exciting question. What are we going to build when privacy isn't just an afterthought or an add-on, but a guaranteed fundamental property of the system itself?